Okay, so I'm continuing with section 6.2. We're talking about the formulas. And on our last video, we were talking about this formula. This is probably, I said, the one I get the most questions about online. And it's really a matter of how do we get these things in our calculator. So I encourage you to keep practicing with your calculator. And they're all a little different. There's not like a standard calculator. They're all, some use an up arrow for exponents. If you were doing 2 to the third power, for example, some calculators you do 2 and the caret button makes it at 2 to the third. Make sure you're getting 8. Some calculators have an X to a Y looking feature or a Y to the X, but that's your feature for that. Make sure you're getting 8, so practice that. And then some have sort of a box here to make it superscripted. So kind of look for that. So like I said, they're all just a little bit different. But for typing in this problem, we're talking about the compound interest formula, and this one shows up in your homework. It's A equals P parenthesis 1 plus R over N close parenthesis, and it's raised to the exponent NT. So there's 2 parts to the exponent, is why I get the most questions on it, I think. So in our example, we put in $100 for our p-value. That's how much money we invested. We're saving maybe, and we want to compound that money. $100. The 1 is just part of the formula. The rate of interest will be given in all your problems. So for this example, I use 6%. Of course, you have to change it to a decimal. So always remove the percent sign before putting it in your formula. And then the n value, which we don't really talk about that so much in this section. Just know that it's repeated. The n is here and here. So whatever they tell you n is, you put it in both of those places. And then t stands for time. So, what did I have? 5 years on that? No, I had 2. Sorry about that. I had 2 years for my example. So to get that out of our calculator, you need to tell your calculator that the 6 and 2 are both exponents. The number one mistake I get on this is if you type it in as 100 times, I think pretty much this part goes okay. It's very straightforward. But then students do up arrow or exponent to the 6 times 2 like that. That will give you a wrong answer, okay? And that's because your calculator knows order of operations. It will do the parentheses first, then it will do the exponent, and it only knows that the 6 is an exponent because you did not tell it, you have not told it that the 6 and the 2 are both exponents. In this writing, it does not know that. So you need to tell it by a parenthesis around the 6 and the 2 for the answer to work out correctly. Then your calculator knows, okay, up arrow to the 12th, that multiplied together. So that's what I would tell you to watch out about that. So everybody pause the video and try typing it on your calculator and see what you get, and I will also to tell you the correct answer. All right, so I'm getting 112.6825. When it's a money question, you want to round it to the nearest penny. So the 2 would determine whether you round up or not. It does not round up. So it's 112.68 cents. So your $100 in 2 years, turned into $112 and some change. So pretty nice. Okay, now let me give you another one to try on that. So let's say we have P equals $500 and R equals 6.2%, N equals 2, and T equals 9. So I'll ask you to pause the video and try that example, please. Okay, so the inputs would be plugging in our formula. P is 500. The 1 is part of the formula plus 6.2%. We need to go 2 left. Anytime you have a percent sign, you go 2 left to get rid of the percent sign. So it makes it 0.062 for R. N is 2. We use it in both of these places according to the formula. And T is 9. So those are your inputs. And then the rest is really getting your calculator to do this. So again, you can pause if you need to and try that. So we'll have the input for your calculator will be 500 times parenthesis 1 plus 0.062 divided by 2 raised to, and this is the important part, you have to parenthesis that 2 times 9. Or just go ahead and know it's 18. Call that 18 and then you just say up arrow to the 18th. That solves the issue. But let's see what that should be. Okay, I'm getting 866 and to the nearest penny is 22 cents. So our $500 grew to $866. So that's nice. The question was, how much interest did you gain? 500 of it was your own money that you had started with, so it's gained like 366 and 22 cents of it is interest, the growth that you got for investing the money. So again, that was $500 invested at 6.2%, although it was for a long time, 9 years, and it was compounded. All right. The next thing I'd like to talk to you about is solving for a specified variable. That's the other big concept in this section. So if we're looking at example 4, it says to take this equation and solve it for y. So we're not really inputting all the values like we were just a minute ago. So there's two big concepts in this section. What we just did, working with formulas, and then the second big thing is rearranging equations for one of the variables. So we're not really going to solve anything, but just rearrange this. This is going to help us in a later section. We do this in our graphing. So if we were going to solve this for y, all right, you notice your string of terms. Here's your y term, the 5y. We want to isolate 5y on one side and everything else onto the other side. So the terms here that I see that aren't needed, like I just want the y term here, I want to take to the other side. So to get 2x over to the other side, you minus 2x, that cancels it off of that side, and then you minus 2x from this side, which sort of just is like you take a term and throw it across the equal sign. When it crosses that equal sign, it's going to be the opposite sign. Right here is a positive 2x. When I move it across, it becomes a minus 2x. Same thing for this minus 10. I'm going to move it across, and it will be a plus 10. Now, there wasn't anything over there to start with, so it's just 0. So now what we've got, the 5y is on the left side, and on the right side, we have a negative 2x and a positive 10. So we're making progress to get the y alone. We're solving for y. We could have solved it for x if you're thinking that, but that wasn't the directions were for y. Then to get y alone, y is times by 5, so we will divide out the 5 to each side. That brings the 5 divided by 5 is 1, or 1y. And then this side, you could leave it like this. That's not bad. And some of the solutions will leave it in just one fraction form. I'm checking your book. They did divide this up though. So this is correct, but this is probably more preferred to write it as two fractions. This is divided by 5. There's two terms here, the negative 2x divided by 5 and the 10 is divided by 5. So pull those apart as two separate fractions. Negative 2/5 with the x and 10 divided by 5 is 2. And then that would be our preferred form. All right, I'm going to ask you to do that, to practice that. So let's say we have 3x plus 7y equals 9. Let's solve that for y. So you can pause the video here, but I'll continue talking. To solve for y, any terms that do not contain y, I take to the other side. So that's 3x, I'm going to move across the line. So positive 3x when moved over becomes a negative 3x. The 9 was already there, so bring it down, it's a positive 9. Doesn't matter which one's in front, by the way. Then to solve for y, because that's times 7, to get the 7 to cancel, we divide the 7 off. We have to do the same thing to each side. That gets y alone, which is solving for y. And then do these separately. Negative 3 divided by 7, that fraction is with the x, and then the 9 is divided by 7. If these fractions were reducible, you should reduce, but this example they did not. Okay, let's do that again. Okay, in this example, again, solving for y, we want the y alone on one side, so I'll throw this x term across. Bring down your minus 6y on the left. The minus 5x becomes positive 5x. The 12 is already there. Bring it down. Divide by what's on your variable because that's an understood time sign. Dividing will undo that. Negative 6 divided by negative 6, we divide by the exact same thing. When we do the divide, we don't change the sign. I don't know if we're noticing that, if that's something I need to mention here. When we throw a term across the equal sign, it changes the whole front sign of that. So we do the opposite when we throw it across the line. When you are dividing, to get rid of this negative 6 that's multiplied, you divide by exactly the same sign because it's a different thought. We're trying to cancel negative 6 divided by negative 6 makes positive 1. You want that to be positive 1y, which is the same thing as just y. So dividing by the same sign there, we do the same thing to each side. So when you do this, we want to say these are two separate fractions here. This 5x is divided by negative 6, and this 12 divided by negative 6. That actually works out to be minus 2. So to clean that up a bit, this negative in the denominator would probably look more natural sitting outside of the fraction like so. Now we're going to use this in the next bit to graph a line. This is actually called y equals mx plus b form. So let me go ahead and mention that because it does mention it in your book in this section too, that you need to know that this is the slope, whatever shows up in front of your x, that's the slope of your line, and the b, the last number, is where it crosses the y-axis, the y-intercept. So slope-intercept form of a line, and we'll talk more about that when we get to that section, but just be aware that's kind of why they've brought that into that. Okay, let's do one more example. So this one's a little more generic, and it's example 5. It's a statistics formula again. Our statistics examples uses the Greek alphabet a lot, you'll notice. But anyway, here's one of our statistics formulas we're going to use. The very last chapter we do actually, and this asks us to solve for x. Solve or rearrange it might be a word. Solve it for x. So you want this x term alone on one side, like we were trying to get y alone. To do that, because this one has a fraction in it, and you could think of this as being z over 1, the first thing I would suggest is remove the fraction by cross multiplying. Since it is a proportion, a fraction equal to a fraction, we can cross multiply those. The cross products have to be equal. So z times the sigma should equal 1 times the x minus u. So that helps us remove the fraction. And then our goal is to have x alone. So now we've got this counts as a term, 1 term, 2 terms, 3 terms. Again, to get x alone, we can simply throw terms back and forth across the equal sign. So I throw that over there, and then there's x alone. So the x sigma, and then the minus u becomes plus u. And I know that might look backwards, so you could rewrite it. If this equals x, then x equals that. So they're just equal sides. So we could rewrite it in this order, and that might look a little better to you.